This video we will discuss about how does the blockchain work. In short, a blockchain is a list of data records that works as a decentralized digital ledger. The data is organized into blocks which are chronologically arranged and secured by cryptography. The earliest model of a blockchain was created in the early 1990s when the computer scientists Stuart Hobber and physicist Scott Stornetta employed cryptographic techniques in a chain of blocks as a way to secure digital documents from data tampering. The work of Haber and Stornetta certainly inspired the work of many other computer scientists and cryptography enthusiasts, which eventually led to the creation of Bitcoin as the first decentralized electronic cash system. Although blockchain technology is older than the cryptocurrencies, it was only after the creation of Bitcoin in 2008 that its potential started to be recognized. Since then, the interest in blockchain technology has been growing gradually, and cryptocurrencies are now being acknowledged on a larger scale. Blockchain technology is most used to record cryptocurrency transactions, but it suits many other kinds of digital data and can be applied to a wide range of use cases. The oldest, safest, and the largest blockchain network is Bitcoin, which was designed with a careful and balanced combination of cryptography and game theory. How does blockchain work? In the context of cryptocurrencies, a blockchain consists of a stable chain of blocks, each one storing a list of previously confirmed transactions. Since the blockchain network is maintained a myriad of computers spread around the world, it functions as a decentralized database. This means that each participant maintains a copy of blockchain data and they communicate with each other to ensure that they are all on the same page. Therefore, blockchain transactions occur within a peer to peer global network, and this is what makes Bitcoin a decentralized digital currency that is borderless and censorship resistant. In addition, the most blockchain systems are considered trustless because they do not require any kind of trust. There is no single authority in control of Bitcoin. A central part of almost a central part of almost every blockchain is the process of mining, which relies on hashing algorithms. Bitcoin uses the SHA-256 algorithm. It takes an input of any length and generates an output that will always have the same length. The output produced is called a hash, and in this case is always made of 64 characters or 256 bits. So the same input will result in the same output no matter how many times the process is repeated. But if the small change is made to the input, the output will change completely. As such, hash functions are deterministic, and in the cryptocurrency world, most of them are designed as a one-way hash function. Being a one-way function means that it is almost impossible to calculate what was the input from the output. One can only guess what the input was, but the odds of guessing it right are extremely low. This is one of the reasons why Bitcoin's blockchain is secure. Now that we know what the algorithm does, let's demonstrate how a blockchain works with the simple example of transaction. Imagine that we have Alice and Bob along with their Bitcoin balance. Let's Alice owes Bob 2 Bitcoins. For Alice to send Bob that 2 Bitcoin, Alice broadcasts a message with the transaction for that she wants to make to all miners in the network. In that transaction, Alice gives the miners Bob's address and the amount of Bitcoins she would like to send along with a digital signature and her public key. This signature is made with Alice's private key, and the miners can validate that Alice in fact is the owner of those coins. Once the miners are sure that the transaction is valid, they can put it in a block along with many other transactions and attempt to mine the block. This is done by putting the block through the SHA-256 algorithm. The output need to start with a certain amount of zeros in order to be considered valid. The amount of zeros needed depends on that's called the difficulty, which changes depending on how much computing power there is on the network. In order to produce an output hash with the desired amount of zeros in the beginning, the miners add what's called a nonce into the block before running it through the algorithm. Since a small change to the input completely changes the output, The miners try random nonsense until they find a valid output hash.